All right. Can we get a bit more participation going? So in this one here, we have a table where we have time and we have velocity. So when we draw this graph, which goes on the x-axis and which goes on the y-axis?
Time with the x-axis.
Well, even if you didn't know that, they tell you it right here. So 4 marks for drawing this. Now, to make life easier, I'll just get Excel to draw it here for me. Insert, graph, chart, scatter. I want it like this. Yep. So the data labels name for range. Okay. Okay, come on. So there you go. There's the graph. Hadino, are you focused now? Come on.
Yeah.
Good. Right, so that's my graph. I just drew it there. So that's what you need to draw on the exam. When you put all the points on it from this table, it will look like that. So can you just do a rough, quick sketch in your notebook? The key thing here, let me shrink it a little bit here for you. Get rid of this here, and then let me shrink that a bit. Okay, well, you can see it there.
Which question is
This is section B, question 1 in the workbook. I have to upload the workbook still, I know.
I have to draw it.
Roughly, please. Okay. After you draw it, the first question, that's 4 marks. 4 marks if you can draw. Congratulations to you. Second one, use this graph to calculate the acceleration. So the acceleration from the graph, what's the acceleration from the graph? It's the slope. So if I look from here to here, what's the height? 16. And what's the horizontal? 4. So the slope would be 16 over 4. Yeah, so 4. So that is 1A1 and now 1A2. 1A2, the acceleration is the slope, which is 16 over 4, which is 4. 6 marks so far, we have 1. Use your graph to calculate the deceleration. So what's the deceleration? That's this one here. You need to be a little bit more careful. What's the height? Is 8, because it's from here to here. And what's the base? 4. So now the deceleration, or if you want to call it the acceleration, would be minus 8 over 4. So that's minus 2. So 8 marks. Now, next one, calculate the total distance.
Area.
The area. Okay, so firstly, let's do this big triangle at the start. What's the base? 4. So give us a calculator. So we'll keep total on our calculator. So it's half the base, and what's the height? 16. Good. So that piece at the start is 32 for the start just. Now the next piece, this is a rectangle in the middle. So what's the base? 2 and the height? 16. So that area would be also a 32. Next is this triangle here. What's the base? No. 4. And the height?
8.
So a half times 8 times 4 is 16. And then finally is this rectangle here, which you can't really see. 4 multiply 8.
8, yeah.
Which is 32. So that would be 96 plus 16. So answer is 112 meters. The total 4 areas added together. 4, 5, 6, 7, 8, 10 marks so far for that. 10 marks, 10% of the exam. 10% of the exam I did in 5 minutes, okay? So the Newton question is a good question. If it comes up, you definitely do it, without exception. Right,
You
now
have to choose.
choose 4 from 6.
Yes.
4 from 6. No, 3 from 6. 24. 3 from 6. 3 from 6, yeah. Right. After 10 seconds, the train moves at a constant velocity of 8 until it collides with a stationary truck. So what type of problem is this when you have the collisions? The momentum one.
Observation.
Yeah. So here is one. Here is the other one. So the car is 2,000, or the truck is 2,000, and it's at rest. And then the train is 8 meters per second, and its mass is 15,000. And before I even look at the question, what do you think they're probably going to ask? What do they usually ask here?
The velocity after the collision.
The velocity, well, firstly the momentum, but then after that, the velocity after they collide. So this is where you need conservation of momentum. So m1 u1 plus m2 u2 equals, and then after the collision they're together. What's their total mass? It'd be 17,000, and we don't know their speed. Train plus car equals, they're going to have a bad time. Right, so that plus 0 has to equal 17,000 times x. Avenue, I'm tired, give me the x.
So it's 8 times 15,000 over
17,000.
17.
So it should be a little bit less than 8, like 7 maybe. 17?
No, it's 7.0588. So it's 7.1.
We did this question before.
Possibly.
And we had this for the exam.
Maybe, yeah. Maybe. Okay. Actually, let me look at what they actually ask. So first, find the velocity. Well, there you go. All right. Part 2.
We always ask kinetic.
Kinetic before, kinetic after, and the change. Look at that. 6 marks, okay? Kinetic before, kinetic after, and the change. So the kinetic energy before is a half mv squared. Abhinav, give me that, please. And Curdy, give me this one, the kinetic energy afterwards. A half v squared.
Why did you put
So the
64?
first one is
8 squared.
the first one is 48,0,0,0. So 4 zeros.
All right.
4, 2, 8, 4,
Slow down there, Curdy. 4.
8, 2, 8, 4, 8, 1.
And therefore the last part, provided that you can do minus. No, it's not what is, but explain. Why is there a loss in kinetic energy?
Heat, sound.
It's sound.
Heat and sound took some of the energy, some of the kinetic energy. Boom, 20 marks. If you get Newton, you are doing it. Right? Next one now. And that's it.
Wait, could you go back for a second?
Yeah.
Just don't move the thing. Does it look like a dog up there?
Yeah, it does.
What?
Eyes
Yeah,
closed.
you know, like in the cartoons.
If you draw,
Here?
if you make
Yeah.
like a
Oh!
circle around it.
Oh, yes.
Wow, Brandon.
You mean like here?
Yes.
Do you want like a tongue sticking out or something? Or?
No, it's already got the little muzzle. It's fine.
Your imagination.
I know.
Is it really this boring to you?
No! when I'm reaching these levels of like energy deficiency, I just
But you have barely done any work
I
today.
know,